Hello. So the goal today in this video is to review solving equations. So you should be taking notes in your algebra notebook. And when you take notes, you want to title it. So today's title is solving equations. And then put the date. So maybe it's September 25th. I'm not sure what day you're watching this, but put the date there as well. So today the goal is to review solving equations. So we're not going to go and look at every example in the whole wide world, but we do want to think about carefully about what different types of problems we might encounter. But in general, the goal when you solve an equation, when someone says solve, and it's an equation with a variable, your goal is to get the variable together. So you might see x's all over the place. You need to get them together. And that usually means on one side of the equation. Then you need to also get them alone. So you want the only thing on that side of the equation to be the variable. And you always use legal moves. And you should have learned those legal moves over the last 2 years. And so we'll review those legal moves together and kind of how to be careful with how you organize your thinking. So you're going to see 3 examples. They're kind of the 3 levels that you should be fairly proficient with, maybe with simple errors, but you should have a fairly good understanding of how to solve these types of equations. If not right now, then hopefully you get better by the end of this lesson today. And then hopefully with some more practice down the road, you'll tweak and get better and not make as many silly errors, okay? Because silly errors are common. Math teachers still make silly errors. So definitely call us out on our silly errors too. So here's our first example. So get the variables alone and together and alone. So right now I see only one variable. He's already together. There's no other y's, just that single 4y, but I need to get him alone. So my first goal is to get rid of the minus 18. So that's kind of how I decide what I'm going to do first. Together and alone, they're already together. Now I get them alone. So again, hopefully your math teachers in middle school taught you the train tracks, they might have called it, but you want to make sure what happens on the left also happens on the right. Both sides have to have the same thing happen. So you want to keep an eye on that, and that's why we draw those lines. That's legal moves, because it keeps it equal. So in order to get rid of the minus 18, we have to add 18 to both sides, because negative 18 and adding 18 make 0. We can also think about it as we're undoing the subtraction with addition. So we could subtract 18, then later we add 18. In the end, it's a wash. They go away. So in the end, I let the 4y alone. But it's not entirely alone. So on the right, I added 7 plus 18, got 25. But the y is not entirely alone. There's still that 4. Remember, that means there are 4 y's over there. But I just want a single y. I want to know what one y is equal to. And so we do another undoing process, which is divide. And we divide because this 4y means 4 times y. And we're undoing the timesing by dividing. We also know that 4 divided by 4 is 1. And whatever we do to one side, we have to do the other side. So we have to divide the other side by 4 as well. Now we have the y alone because we have one y. Remember, we don't need that number 1 in front of the y. Equals, what's 25 divided by 4? I'll do that in my head, but you might need a calculator. That's totally cool. This is 6.25. There's my answer. So again, your goal is to get your y alone and together. He's completely alone now. So when we say alone, we want just a y thing on one side, and it might be 4 y's like we saw, and we get it completely alone by getting rid of the 4 at the end. So let's take a look at the next example, because it of course has a slightly more difficulty to it, as we've seen throughout our math career. Don't be afraid to pause this video if you need to catch up. So example 2. So now we have x's. We look at the overall equation and we see x on the left and on the right, and we think, okay, I need alone and together. Okay, they're not together, so I need to start with together, because they'll never be alone if they're all over the place. And so I draw my train tracks to keep things balanced, and I think about, what do I need to do to get them together? Well, I don't like them on both sides, so I need to get them to one side. I often look at it and say, I want to get, I don't like negatives, so I'm thinking ahead. So what I'm going to do is put a negative 3x on both sides, because I know that these two on the right won't make a negative. Negatives, we make more mistakes with. So I figure might as well try to keep things as positive for as long as possible. So we do the same thing to both sides to keep it balanced. We're doing minus 3x because this makes a big old 0. 3x minus 3x is 0. And that goes away, so we're left with negative 4. Let me make that cleaner for you. We're left with negative 4 equals, but on the right, 5x minus 3x is 2x's plus 15. So we got my x's together. Now we need to get them alone. And so I find where my x's are. I focus on where the x's are. Always focus on the x's. And I think I want to get him alone, so let's get rid of the 15. So my next step is to minus 15 because it's the opposite of addition, and it's going to make it turn into 0. But of course, on the right and on the left, you have to do the same thing. So I do the same thing left and right. Now I'm left with, on the right, just 2 x's remain because this made a 0 and these 2 x's were left. And on the left, negative 4 minus 15. I'm in the whole 4. I go down 15 more. That's negative 19. And again, if you want to punch this in your calculator, you type in negative 4 minus 15. I would never use your iPhone as a calculator. It doesn't understand the negatives and the subtractions the same way that we understand it. So you should use the Desmo Scientific Calculator. But you'll get negative 19, okay? So I'm going to erase that so it's not messing with my work. But that's what you punch into your calculator. So my last step, it's alone, but it's not entirely alone. I still have that 2. So my next step is to divide by 2 to make the 2 turn into 1. Again, you're undoing the multiplication that's hiding right there, and you get x alone. And we do it, of course, to both sides. Divide by 2. Negative 19 divided by 2, that's almost negative 10. It's negative 9.5. Again, calculator's your friend here if you want to check my work. Negative 9.5, and there's your answer. So alone, together, every time, alone and together. So let's take a look at the next one. Again, thinking about the same mantra, alone and together. So this time, example 3, we're solving for a, because that's my variable. And I notice where all the a's are. So we see an a here, we see an a here, we see an a here. So they are everywhere. They are certainly not alone or together. And so I do want to draw my lines to keep things balanced. And what I see is that I see a's on the same side, and those can be rearranged. That's because you can kind of do combining like terms when you have a's on the same side. So I actually get to do this math. 4a, take away 2a. That leaves me with 2 a's. 4 take away 2 is 2. So 2a. And then I still have the minus 17. On the right, I just copy what's on the right. I did not add anything to the left. I simply simplified the left. So I don't need to do anything to the right side. So that's it, 12 plus a. Okay, now we're ready to keep going. Now it looks a lot like the previous example. I have a's on both sides. I think strategically I want to get rid of this a because it's a single a. Remember, when there's no number in front, that means there's one a. So I'm really subtracting 1a from both sides to make the a's over here disappear. And on the left, 2a minus 1a will give me 1a. And we still have that minus 17. We just copy him down. And then we copy the 12 on the right because the a's made a 0. Now we're ready to finish solving for a. So alone, they're not alone, but they're certainly together. All my a's are together. Now we got to get them alone. So my next step is to add the 17 to make them alone. And of course, I'm adding because that undoes the subtraction. We do the opposite to make it a 0. And that makes this go away. And I'm left with my 1a. He's alone. On the right, I get 29. Now, because I wrote the 1a, you might be thinking, hey, now I need to divide by 1 to make the 1 go away. But remember, 1a is the same thing as just a. I just wrote 1 just so you could see my thinking, but you don't need to write the 1. In fact, we know 29 divided by 1 will just be 29. So the answer is 29. You could have been done on the previous step, but that works too if you want to be consistent. So those are the 3 examples you should have in your notes. Now you want to refer back to those examples when you need help, but you'll also start to see that there's some other teachers' videos that might explain it in a better way that works for you. So use those other examples to help you understand it. And of course, reach out to your teacher if you're still struggling. But keep those notes in a smart spot so you can come back to them whenever you're working on assignments in this class. Thanks for watching. Keep up the good work and ask your teacher if you need more support.